Hey everyone, welcome to week 11, moving right along, continuing our work with probability. So just some other looks at probability, some more practice. This one's titled World Series. So in this problem number one, we're comparing some real world data with how things would look, or comparing it to how it would be on theoretical probability. So in this one, we have some data. The World Series, we know it was held 70 times in that time frame. And then 33 of those, one team was behind some stage 3 games to 1 game. So if you're not familiar with baseball and World Series and all that, it doesn't matter. But the point of a series is that it's the first one to win 4 games wins, right? So the most games that could be played are 7, and the least would be 4, right? And so in those World Series, at some stage, there was a team that was behind 3 games to 1, meaning one team had won 3 games at this point, and the other team had won 1 game. And then of those, when it was 3-1, only 3 times of those 33 series did the team that was behind, the one that had only won 1 game, went on to win, which would mean they would have to win 3 in a row and win the 4 games to 3 before the other team got 4 games. Okay, so the question is, how would that compare to pure chance? And we're going to do that, assume that teams that reach the World Series are probably pretty evenly matched. They're good teams, and each game might be a 50-50 chance of who wins. Okay, so to experiment with this, you'll need a coin, and just pretend the 2 sides of the coin represent 2 teams, the Havana heads versus the Tennessee tails. So you flip the coin, which represents a game, and then if it's heads, Havana won the game. If it's tails, Tennessee won the game. Okay. And what I would like you to do is simulate 20 World Series. So that means you're going to have to flip a coin. So I did one for you. World Series number 1, it went HTHTHH. So in that scenario, Havana won the World Series 4 games to 2 games. Okay. And neither team was ever up 3-1, right? It was 1-0, 1-1, 2-1, 2-2, 3-2, and then finally 4-2. So you're going to experiment and just run some simulations. If you don't want to flip a coin or don't have one available, just go ahead and use that website that we referred to last time that has the coin flip simulator. Okay, and then just go do that, and then you're just going to answer some questions. Was there any time that you had a series that was behind 3-1? And if there is one, right, if you had one that one team was up 3-1, meaning like maybe it went HHHT, that would be Havana up 3-1. How many series did that team that was behind come back to win? So you would have to see an HHHT and then TTT, right? And that would represent the series coming up for the tails 4-3. Okay. And then just compare that with your results, right? How does your probability compare with the actual real world statistics? Okay. And then the rest of it is just some extra practice with games that we've played before. There's a dice game, and then there's another Monty Hall game with some twists. Okay, so I'll let you experiment with those on your own. If you have questions on them, let me know. Okay. Otherwise, let's look at the other assignment, assignment 17. And sorry, I gotta load it up. This one, again, we just have another probability game. This one involves a box of balls, and there are the balls. There's 3 red, 4 green, and 5 yellow, and each one has a number on it. Okay, so there's 12 distinct balls. Okay, and so for $1, you pick a ball at random and then answer the questions based off of that. So what's the probability that you choose a red? What's the probability that you don't choose a red, etc.? Okay, so some pretty basic probability questions. Think about your formula, number of successes over the total number of possible outcomes, and use that as your guide. You can write your answers as a reduced fraction, decimal, or percent. I'll take any of those answers. Okay, and the more complicated one is if you choose two balls, what's the probability that they're both red? So my suggestion for that one is try to think about the sample space or all possible outcomes by listing them. So list every possible two ball combination, right? So you could do one red and two red, or one red and three red, or one red, one green, one red, two green, two red, one green. All of those two ball combinations, you want to see how many there are. That will be the denominator of your fraction for your probability. And then the top is how many of those two ball combinations are both red. Okay, so see if you can piece that together and come up with that probability. And then again, we've got some review of another dice game and another Monty Hall. Okay, so a lot of review problems here with a couple of new ones. See how it goes. If you have questions, definitely send them my way. Feel free to email me with any questions you have, and I'll help you. Okay, that's it for now. Have a good week, and I'll talk to you later. Thanks. Bye.